What's up, everybody? Welcome back for the second lesson of our digital learning at my basement, okay? So you need to have your unit binder open. Let's move me to the side, okay? We are going to be doing the density lesson today, but first we have to finish up faster flow. Okay, this is the last PO from the last lesson when we were looking at flow rate and other things. So in the last lesson, we covered, as my computer figures this out, here we go. We did demonstrating an understanding of viscosity. We learned that word, and we compared the various viscosities of other liquids. Okay, we are using the inquiry and experimentation method, okay, to experiment with flow rates. Okay, and today we're going to be starting to look at describing the relationship between mass, volume, and density. Okay, mass to volume ratio we're going to look at, and we're going to compare the density of a variety of liquids. Okay, so if you would turn your PO, turn your unit binder to the faster flow PO. Thank you, computer. That was not helpful at all. Okay, so everything up until this PO should be done. Okay, you should have it completed, and if not, if only you had some quarantine time to be stuck in your home to do it. Okay, so we are going to pour molasses. Okay, so in our last lesson, we looked at the viscosity. Okay, and we were actually surprised about how fast molasses was compared to what we thought. Now, today, we're going to do a very similar experiment. Okay. However, we are only going to be pouring molasses, and we're going to be pouring a hot molasses, a cold molasses, and a room temperature. So what I've done is I boiled my kettle. Okay. In case you don't believe me, things first. Pour a little bit more. Okay, you can see, I don't know if you can see on your computer, the steam that's coming off. Okay, so we have regular molasses in a smaller beaker. And the bigger beaker is full of hot water. Now for the cold, we're going to get out my cooler. I'm okay. So what you're seeing here is a bag of ice. Okay. In that bag of ice is a big beaker, a large beaker, 300 milliliter, okay, full of ice. And inside of that is this molasses. Okay. It's sitting there, getting perfect for us. Okay, so I'll put this ice back in the cooler so it doesn't melt on my desk. Get my technology all wet and messed up. Okay, I got a piece of paper, check my table. So, what you need to do now is make a prediction. Okay? We have the hot, we have the cold, and we'll have a room temperature, which I'll pour directly from the bottle. Okay? So, you need to now make a prediction right here. Which temperature do you expect to flow down this cardboard the fastest, and which one do you expect to be the slowest? Okay, rank them in order. And in the chat, hopefully you've calmed down by now. Okay, and you're all focused, you're all in order. Write your order in the chat. Okay, go ahead, do that, and I'll get my camera all set up. I learned my lesson from the last lesson is make my screen as big as possible. Unfortunately, it's not as big as I want. Okay, so hopefully all of your predictions are locked in. Okay, we have hot, we have cold, and we have room temperature. We're going to start with room temperature. Get ready to make some observations in your unit binder. Okay, room temperature. This is the exact same that you saw yesterday. Slow as molasses. Not yesterday, 2 days ago. Okay, there goes room temperature molasses. Okay, write your observations. How fast? Maybe you're at home and you have a on your phone and you have a timer. You want to time it. Put that in your observations. Share that in the chat. That would be awesome. Okay. Now let's do the cold. Okay, so this is coming directly out of the ice. Okay, and here we go. Go molasses. Now already you can kind of see the speed at which it's traveling. So that's our cold. There he goes. Not so fast, big guy. Okay, now we're going to take the hot out. And if you're just joining us, okay, this was in ice cold water or ice cubes. Okay, and this molasses was in freshly boiled water. So here I go. I'm going to pour hot molasses. Boom. Make your observations. Go, 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 go. Make your observations. I'll pour one more time in case you missed that. Okay, incredibly fast. Now, try to think, why does that make sense? What do you know about particle theory and the movement of particles that explains how their temperature changed the rate at which they flowed down the cardboard? Okay, so take this time, get some stuff typed in there. Go, 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 go. Okay. Hopefully, most of the results were what you expected. Okay, but use the idea of particle theory and what we know about how when particles are heated up, how fast they move compared to when you're cold, how slow you move. Okay, get those answers written down. And with the magic of YouTube, we will watch it again and again. Here it comes. So here's another look at the same experiment for regular molasses. There's the cold molasses and the hot molasses. Okay. So look at the speed. It's a pretty normal speed of molasses. Then the cold one, look at it wiggle its way down there. And hot just flew right down. Okay. Fun experiment. Really, really here shows that particle theory, right? And how when particles are hot, they move a lot faster. Okay. And when they're cold, they don't move as fast. Okay. So I'm going to move on and you're going to finish that later. If you need help with that, okay, you sign up Fridays at 2 o'clock and 2:30. Okay, I do science help online, and you can ask me questions. You can share your screen and say, Mr. Staff, help me with this question. Okay? Awesome. Now we're going to look at density. Okay. So next slide, lesson 4 is density. You want to be taking notes here. Okay, so go ahead, get that written, get that done. All right. So here we go, density. Move some stuff out of the way so I can not get dirty. So you saw this graphic before. Okay. We talked about the difference between mass and weight. My camera. Okay, mass is the measure of the amount of matter in an object. You should have that written down from a previous lesson. Whereas weight is a measure of how strong the force of gravity is on that object. Okay, so again, what's different? Which one is different on the moon compared to Earth? Put it in there. Put it in the chat. Let me know. Remind me. I forget. What would Miss Farquhar say? All right. Tell me, which is different? Is mass different on the moon or is weight different on the moon? Okay. And enough time. Your mass is the same whether you're on Earth or on the moon. Okay? It's your weight that changes. Okay. Coming back to here, weight is the measure of how strong gravity is impacting you. So that's why weight is the one that changes, because the gravity is different on Earth than it is on the moon. Okay. So the moon exerts about 1.6 newtons, okay, of mass per kilogram, and Earth 9.8. So much more on Earth. So the Earth is great in a greater way impacting your mass, or your weight, sorry. Okay. In math, my class is learning about volume, and you've learned about volume every year, maybe, I think. Okay, but it's a measure of how much space an object occupies, it takes up. Okay, and you know this, volume equals length times width times height. Just don't happen to have that up here. Okay, length times width times the third dimension of height. Okay, in my class, we're learning about a cylinder. We're learning about the volume of a cylinder. Isn't that perfect for science? Okay. That's my class, volume equals pizza. What does that mean? I like pizza. This slide would normally be on the back wall in our classroom, on our interactive science wall. Okay, and this is intended to help you with some of the upcoming math questions. Yes, there are math questions, and these are the heavier ones of this unit. Nowhere near as hard as the last unit. Okay, but you need to know this. So write this down. Okay, this is just helping you convert. Okay, you need to know that 1 liter equals 1,000 milliliters. Okay, so that'll help you. And then we're also going to say that 1,000 centimeters cubed is equal to 1,000 milliliters. Okay, or another way of saying 1,000 centimeters cubed is equal to 1 liter. Okay, write that down, type it up. I'll give you a second. Awesome. Okay, there's a number of different ways that we can find volume. One way that we can find volume is how you've been doing it in math, is doing calculations. Okay, length times width times height, okay, or using the cylinder. Okay, another one is displacement. Okay, we're going to talk about displacement. This I think is really neat. This is a really cool way of calculating volume. Okay, and 3 is getting readings. Okay, so putting liquid in, so that's what you've been doing all year. Okay, and then reading what line is it at, and we could say, oh, it's 60 milliliters. Okay, cool. Let's move on. So calculations. This is like a typical math question that you've done for years. So let's do it together. Calculate the volume in milliliters and in liters of a container that is 5 centimeters long, 10 centimeters wide, and 13 centimeters tall. Okay? So what is the first thing you do? Well, first let me highlight some important information. Okay? We have our dimensions and what the question is asking us. First thing you always start with is your formula. First thing you always write is your formula. Okay? Math or science. Okay? Then you plug in the numbers you know. So we go back and we can see that length is 5 centimeters. So we put it there, 10 centimeters wide and 13 centimeters tall. So we have our 3 dimensions. Okay, and then we can go ahead, follow bed mass, and do the math. So we have 650 milliliters. So the question did ask us in milliliters, but it also told us to convert to liters. So we come back to this slide, which would normally be on the back wall, okay, that you'll need to make reference to. Maybe put on a sticky next to your desk or wherever you normally work. Okay, we have 3 zeros after this 1. Okay, so all we have to do is move the decimal 3 decimal places. There we go. So convert it to liters. We're going to move it once, move it twice, move it 3 times. So the volume in liters, this would be just over half of a liter. Okay, 0.65. Okay, got that down, and I'm going to get our next display ready to go. Okay, now we're going to talk about displacement. Now, if you are paying attention, we come to this slide. Skip that one. For me, it's slide 22. Okay. Question 1 asks you what method of determining volume, okay, or describe each method. So you can show what we just did. Volume equals length times width times height. Okay. Now, we're going to talk about displacement here. So maybe you want to take your notes here. That'll help you on the upcoming unit test. Okay. Again, let me turn that off. Okay, here we go. So the word displacement means like being put out. Okay. So make me big. Can I go bigger? So if I pull back to this beaker that I had earlier, okay, the proper way to read this is on the table. Okay, but I'll just show you kind of the camera. We have 150 milliliters in this. Okay. If I was to put a random object if I was to put a marble in there, okay, it would take up space in this water. Okay? And so naturally, the water level will rise. It'll go up. Okay? And the reason it goes up is because the marble is taking space inside. I need to get this higher so that the camera has a better view. So be patient with me here. Not a perfect system. Okay? Now, because the marbles are kind of small, it won't raise, the water level won't raise that much. Okay, so what I'm going to do is I'm going to use this smaller beaker of molasses. Okay, and as I put it in, so right now the water level is at 150 milliliters. But when I put it in, you immediately saw the water level rise. Okay, let me do that again. Pull it out. The water level is at 150 milliliters. Okay, I put it in, and the water has raised to, what is that? That is 225 milliliters. Okay? So it was at 150 milliliters. And then when we put it in, the water has been changed to 225. So the water level has gone up. It has gone higher. Okay? This increase is what we call displacement. Okay? Whatever we put in that water has displaced that water by a certain amount. By how much? So displacement, or calculating volume using displacement, says that whatever this middle area, okay, that's how much the water rose, because that's how much space or how much volume that tiny beaker is taking up. And so we could say, if we could figure out how much that space is, that's the volume of the thing that we just put in the water. Okay? You might be a little confused, or you might be like, oh, I get it, Mr. STAV. No worries either way, because that's beginning of a new concept. So be patient with me here. And let's go back to the PowerPoint and kind of just look with the same demonstration, but with diagrams and animations. Okay? So here, the water level is at 15. Okay? So to calculate displacement, remember, write this into your notes. Okay? We need to first record the initial volume. Okay? This is the volume that it starts at. Initial. Okay, type that in. Mr. STAV, do you think this is important? I absolutely think this is important. You want to know this. Okay? Place the object in the water. Okay, so let's choose a rock and put it in. Okay, now you see as that rock goes into that beaker, that water rose quite a lot. Let's do it again. Here comes the rock. There it goes. Okay, and finally we're going to record the final volume. Okay, so what's the final volume? 40. It is not easy writing with a trackpad. Okay. Of course, you know I'm going to animate it, so. Oh, I didn't animate it. There it is. Finally, to figure out this middle spot, you're going to subtract the initial volume from the final volume. Okay? So, let's add these words here. We have initial, what it started at, and we have final. Okay? So I'm going to say, for my example, it's going to be 225 take away 150. All right? Put it in the chat. What is 225 take away 150? No shame if you've got to use a calculator, use a calculator. 225 take away 150. Mr. Calculator, what do you got? Okay, so I got 75. Okay, so for my example, the water started at 150 milliliters. Okay, it started at 150 milliliters. I placed an object in, and it raised to 225 milliliter. That amount that it raised, we call the displacement. The displacement was 75 milliliters. That tells me that this object that I put in there has a volume of 75 milliliters. Okay, let's go back to my animations. So I'm taking my final volume of 40 milliliters and I'm subtracting what I started at, 15 milliliters. And I can know that this difference here, there's another math term, difference, is 25 milliliters. This rock increased the volume of, or the amount of water, or the height of the water by 25 milliliters. So this rock has a volume of 25 milliliters. Why would we do this? Okay, because how could you calculate the dimensions of this rock, right? Because it's not as easy as I put just a cube in, right? And then I could do length times width times height. Okay, what I have to understand is that sometimes we need the volume of weird shaped items, and so displacement is a perfect way of doing this. Okay, it's used in cooking. Okay, it's used in lots of different uses, but this, I actually think displacement is kind of cool. It's more fun to do than just the calculation method. Okay, and the third method is called reading. Okay, and not like read a book. This is like get a reading, and essentially we kind of did that, right, by reading the numbers on here. Okay. Now, in our last lesson, we talked about adhesion, and we talked about how water will actually adhere to the surface of the tube, and it creates a meniscus. Okay, so when we look at eye level, we're not looking at the top of this meniscus, we are looking at where it levels out. That's where we get our volume readings from. Okay, very, very important. Okay, I would say very important for the rest of the year, but I don't know how many chances you're going to have a measured beaker in front of you. Okay, but hopefully, if you do some measurements in the kitchen, you can see this out. Okay, so to do a proper reading is what you're going to put in your notes. You're going to bring your eye to eye level, okay, with whatever you're doing the reading of. Okay, so I don't want to be looking from here. I want to get down and I want to look right at eye level. Okay, so I can really see where that meniscus is. Okay, and read the bottom of that meniscus. Okay, so you should have 1, 2, 3, these 3 things filled in. Okay, that concept of displacement is going to be important as we do a lot of the math calculations coming up, okay, and on the unit test. Okay, so you need to get yourself a little bit accustomed and acquainted with that, okay?